Hello students, now we are going to see about trigonometry. Introduction to trigonometry. For that, let me consider a right-angled triangle. What do you mean by right-angled triangle? It will have 90 degrees as one of its angles. How many angles will be there in a triangle? 3 angles, right? For example, if I consider this triangle ABC, it has 3 angles, A, angle B and angle C. Let me take this B angle as 90 degree. If it has one angle as 90 degree means it is an right angle triangle. Is it clear? And I use the notation for representing the angle at the vertex A as A. So ABC rather vertex, right? A, let this angle is A. Okay, and here we have 90 degrees. Using this triangle, we are going to write some formulae. After that, we will proceed. What is the formula for finding sine A? Sine A is equal to opposite side by hypotenuse. What do you mean by hypotenuse? You know Pythagoras theorem? Sum of the squares of the other two sides is equal to square of the hypotenuse. Am I right? Right. So using Pythagoras theorem, what we have is AB the whole square plus BC the whole square is equal to hypotenuse is AC, so AC square. So we have using Pythagoras theorem this equation. Okay, so this is hypotenuse, this is our angle, the side opposite to that is BC, that is the opposite side, and which is adjacent to A, that is the adjacent side, and this is hypotenuse. So this is opposite, which is opposite to the angle A and adjacent to A, and this is the hypotenuse. Now come to the formula for sine A. Sine A is equal to opposite side by hypotenuse. So here, which is the opposite side? BC is the opposite side. So BC by hypotenuse is AC. So BC by AC, sine A. And cos A is equal to adjacent side by hypotenuse. Which is the adjacent side? AB is the adjacent side. By hypotenuse is AC. So AB by AC. And tan B is equal to opposite side by adjacent side. Opposite side is BC, adjacent side is AB. BC by AB. I repeat the formula. Sine A is equal to opposite side by hypotenuse. So here BC by AC. Cos A is equal to adjacent side by hypotenuse. AB by AC. And tan A is equal to opposite side by adjacent side. So BC by AB. And come to the formula for cosecant, secant and cot. Cosecant is nothing but 1 by sine. That means 1 by BC. It is 1 by BC by AC. So when we take the inverse, AC will come to the numerator and BC in denominator. So the formula is AC by BC. Here sine A is opposite by hypotenuse. Excuse me. Cosecant is hypotenuse by opposite. Now secant A. Secant A is equal to 1 by cos A. What is the formula for cos A? Adjacent side by hypotenuse. So secant A is equal to hypotenuse by adjacent, that is AC by AB. This is the formula for secant A. And cot A is equal to 1 by tan A. So adjacent by opposite, that is AB by BC. Is it clear? And these are some formula which we are going to use in our problems. Tan A is equal to sine A by cos A. Cot A is equal to 1 by tan actually. It is the inverse of tan. So cos will come in the numerator, sine will come in the denominator. Cos A by sine A. And this is an important formula. Sine squared plus cos squared is equal to 1, and 1 plus tan squared is equal to secant squared. 1 plus cot squared is equal to cosecant squared. So these formula we will use in the problems, and these things actually these things are not in your syllabus. Complementary angles. Sine of 90 minus a is equal to cos a, tan of 90 minus a equal to cot a, secant of 90 minus a equal to cosecant a, cos of 90 minus a equal to sin a, cot of 90 minus a equal to tan a, and cosecant of 90 minus a equal to secant a. These formulae just I have written, but it is not in our syllabus. Okay, only you have to study this one. Tan a is equal to sin a by cos a, cot a equal to cos a by sin a. Sin squared a plus cos squared is always 1. 1 plus tan squared is secant squared. 1 plus cot squared is cosecant squared. Clear? This is the important table which you have to study and you have to memorize the values. Okay, so these values, we have taken some values for A, angle A, and respective sine, cos, tan, cosecant, secant, cot values are given in the table. Okay, so angle starts from 0, 0, 30, 45, 60, 90, and sine values are 0. The sine values are 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Okay, how it starts now? We have to take 0 here first, 0. Then quarter value, that is 1 by 4, root of this one. Root of 1 by 4 is 1 by root 4, which is 1 by 2. That is this value. Then after quarter, half will come. So 1 by 2, we have to take square root of it. So root 1 by root 2, which is 1 by root 2, this value. Then 3 by 4. So 3 by 4, square root of 3 by 4. So root 3 by root 4, which is root 3 by 2, this value. Finally 1, square root of 1, that is 1. So starting from, we have to start from 0, then quarter value 1 by 4, then 1 half value 1 by 2, then 3 by 4 and 1. We have to take square root to every term and we have to write in order. So square root of 0, square root of 1 by 4, square root of 1 by 2, square root of this is 3 by 4 alone. Square root of 3 by 4, then square root of 1. All these values we have to write in order. Then cos A means we have to start from the back side. 1 will come here, root 3 by 2, then 1 by root 2, then 1 by 2, 0. These things you have to fill up. After that, easily we can write it down. Tan A. Tan A, what is tan A formula? Tan A is equal to sin A by cos A. So for this value, what is sine value? 0 by 1, which is 0. For this value, sin A by cos A, 1 by 2 by root 3 by 2. 2 will get cancelled. 1 by root 3. For this, 1 by root 2 by 1 by root 2. Root 2 will get cancelled. 1. For this, root 3 by 2 by 1 by 2. 2 will get cancelled. Root 3 by 1, that is root 3. For the final one, 1 by 0. Now you tell me what is the value 1 by 0? It is infinity. Infinity means it is the value which is not defined. So this is not defined. Okay. Now cosecant. What is cosecant A? Inverse of sin A. Inverse means already we have 0 now, 1 by 0. 1 by 0 is infinity, it is not defined. And 1 by 2 we have now 1 by 1 by 2. So it is 2. And this is 1 by root 2, root 2. And this is 1 by root 3 by 2. So it is 2 by root 3. And this is 1 by 1. Is it clear how we are getting this cosecant A? Now secant A. Secant A means 1 by cos. So 1 by 1. And this is 1 by root 3 by 2. So 2 by root 3. And this is 1 by 1 by root 2. So it is root 2. And this is 1 by 1 by 2. It is 2. And this is 1 by 0. 1 by 0 is infinity. That is the value not defined. Now cosecant A. Cosecant A means here we have 0. Now 1 by 0 infinity. Here 1 by root 2. 1 by root 3. I'm sorry, not root 2, root 3. So it is root 3. Here 1 by 1. And this is 1 by root 3. And this is already we have infinity. Infinity means 1 by 0. Am I right? So 1 by 0. 0 will come to the numerator. So it is 0 here. Is it clear how to fill the values in this table? So you have to fill up this one. First one row you have to fill up. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. And you have to take in the reverse. After that easily we can write all the values. We are going to state whether the following are true or false, and we are going to justify our answers. The first question is sine of a plus b is equal to sine a plus sine b. For that we are going to use the table. Okay. Sine of a plus b is equal to sine a plus sine b. For checking the first one, I have taken a as 30, b as 60. So sine a value is 1 by 2, sine a is 1 by 2, sine b, that is sine 60 is root 3 by 2. Okay, so what is a plus b? A plus b is 90, sine 90 is 1. Sine 90 is 1. Okay, so now here sine a plus sine b is 1 by 2 plus root 3 by 2. But sine of a plus b is 1. So this result is not true for all a plus b. So this is not true. The value of sine a increases as, and not a, sine theta increases as theta increases. See this table. 0, then 1 by 2, 1 by root 2, then root 3 by 2, 1. Is it increasing? Is it increasing? Yes, it is increasing. From 0, it keep on increasing up to 1. So it is in increasing order. See cos, from 1, it is decreasing. It is decreasing from 1 to 0. So sine A increasing from 0 to 1, cos A decreasing from 1 to 0. Okay, now come to the question. The value of sine theta increasing as theta increases. Yeah, when we take theta from 0 to 45, theta is also increasing, sine is also increasing. But for cos, when theta is increasing, cos is decreasing. Okay, so this is correct. But see this third question, the value of cos theta increasing as, this is wrong because cos theta is decreasing. The fourth one is sine theta plus cos theta for all values. Sine theta and cos theta are equal for all values of theta. Is it true? No. See these values. All the values are different. So no way sine theta and cos theta is equal. So this is not true. Last one, cos A is not defined for A is equal to 0. What is cos 0? It is not defined. Actually this is infinity. That is not defined. Okay, so this is true. So these two are true, other three are false. The next example what we have is, given tan A is equal to 4 by 3, we are going to find the other trigonometric ratios of A. That means we have to find, tan is given, no, we have to find sine, cos, then cosecant, secant and cot. The other 5 we have to find what it is. Okay, so for that first we have to draw a right angle triangle. Okay, so let me draw a right angle triangle. Angle So this is a right angle triangle, right angle at the vertex A, not A, I'm sorry. This is a right angle triangle, right angle at the vertex B. Okay, so given, what is given? Tan A is equal to 4 by 3. Okay, what is the formula for tan A here? Tan A is equal to opposite side by adjacent side. So BC by AB. This is tan A, right? So they have given tan A is equal to 4 by 3. 4 by 3 can be written as 4k by 3k. Multiplying and dividing by k in the numerator and denominator. Actually, why we are doing this? No, 4 by 3 can be written as 4 into 4 by 3 into 4. That is 16 by 12. This is and this, these two are equal. In ratios, we can multiply a common factor both in numerator and denominator. Or we can take this as 4 by 3 into 2 by 2, that is 8 by 6. This is also equal. So either 4 by 3 we can say, or 16 by 12 or 8 by 6. So anything can be multiplied and divided. That constant we are taking as k. So 4k by 3k. And using the formula, what we have is BC by AB. Am I right? So what we can do is we can equate the numerator and denominator separately. Okay. So what we are getting is BC as 4k and AB as 3k. I can represent this here. This is 3k and this is 4k. So I have to find what is this. This is hypotenuse. Using Pythagoras theorem, what we have? Sum of the squares of these two sides is equal to square of the hypotenuse. So AB squared plus BC squared equal to AC squared. AB squared means 3k the whole squared plus 4k the whole squared equal to AC squared. So which implies AC squared is equal to 3k squared is 9k squared plus 16k squared, which is 25k squared. So AC is equal to root of 25k squared, which is 5k. So we got this as 5k. Am I right? So finally what we got for AC? AC as 5k. Now we are going to find all these 5 values. Okay. So what is the formula for sine A? Sine A is equal to opposite side by adjacent. Not opposite by adjacent. It is opposite by hypotenuse. Which is the opposite side here? BC. And hypotenuse is AC. So it is BC by AC. What is BC? It is 4k. 4k by 5k. So 4k by 5k, which is 4 by 5. And cos means adjacent by hypotenuse. So 3k by 5k, so it is 3k by 5k, which is 3 by 5. What is cot A? It is 1 by tan A. Tan A is equal to 4 by 3. So 1 by 4 by 3. 1 by 4 by 3, which is 3 by 4. And cosecant is 1 by sine. So inverse of this. So it is 5 by 4. And secant is 1 by cos. So inverse of cos. So it is 5 by 3. Is it clear? The next problem what we have is, if angle B and angle Q are acute angles such that sine B equal to sine Q, then we have to prove angle B equal to angle Q. For that, we have to take two different triangles, right angle triangles. Let me take these two triangles, triangle ABC and triangle PQR. What is given? What is given? Given sine B equal to sine q. Sine q. What is the formula for sine b? Here it is b, no. Sine b is equal to opposite side by hypotenuse. So opposite side is AC by hypotenuse is AB. And what is sine q? Sine q is equal to opposite side by hypotenuse, which is PR by PQ. So they have given these two are equal, therefore these two are equal. So which is implies AC by AB equal to PR by PQ, which can be rewritten as AC by PR is equal to AB by PQ. I am taking this to this side and this AB to this side. So AC by PR is equal to AB by PQ. If we have ratios, we can equate that to any constant. K is a constant. We are equating the ratio to a constant. So AC by PR is equal to AB by PQ. Using Pythagoras theorem, we are going to find what is BC and QR. What is BC? Here, using Pythagoras theorem, AB squared is equal to AC squared plus CB squared or BC squared. Okay, so BC squared, this can be written as BC squared. So BC squared equal to AB squared minus AC squared. So BC equal to square root of AB squared minus AC squared. And here using Pythagoras theorem, hypotenuse squared, that is PQ squared equal to PR squared plus QR squared. So keep this in the left side. QR squared is equal to PQ squared minus PR squared. So QR is equal to root of PQ squared minus PR squared. That only we have here. Now we are going to find the ratio BC by QR. BC is equal to root of AB squared minus AC squared. QR is equal to root of PQ squared minus PR squared, which is equal to AB squared minus AC squared. Here we have no, in the previous formula what we have is AC by PR is equal to AB by PQ equal to some constant K. From that, equating these two separately, AB is equal to, we can multiply PQ here, so K into PQ. So for AB we can replace KPQ. For AB the whole square, no, KPQ the whole square. Then AC, equating these two separately. AC by PR is equal to K. So AC equal to K into PR. So AC squared means KPR the whole square. So KPR the whole square. Both are having, we can rewrite this as K squared PQ squared minus K squared PR squared. Root of, okay, so K squared is common, so root of K squared into PQ squared minus PR squared. K squared we can take outside the root as K into root of PQ squared minus PR squared. This is what we are getting for BC. So for BC we can write K into root of PQ squared minus PR squared by this, as it is I'm going to take PQ squared minus PR squared. These two will get cancelled. Therefore, we are getting BC by QR is equal to K. Already we have what we have. This is equal to K. Therefore, finally what we are getting, AC by PR is equal to AB by PQ equal to BC by QR equal to some constant K. Okay, see this triangles. So AC, this one AC by PR. this side and this side are the corresponding sides, right? And AB by PQ, AB by PQ and BC by QR. So this side along this side, this side, this side and this side, this side, their ratios are equal. If these ratios are equal means already we know that we have a theorem. If the ratios of the respective angles are equal, those two triangles are similar triangles. Therefore, we can conclude triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. If it is similar means the respective angles are equal. The respective angles means CR already it is equal since 90 degrees. AP and BQ. So angle B equal to angle Q. This is what we have to prove. We proved. So after the ratios, using similar triangle property only, we proved this. Is it clear? Now come to the next problem. We are going to consider triangle ACB, right angle at C. Here it is 90 degrees. And in which AB is given as 29, BC is given as 21 units, and here only we are having the theta. We are going to find two values, sine square theta plus cos square theta plus sine square theta. The second one is cos square theta minus sine square theta. So what we have to find first, cos square plus sine square. Already we know that sine squared plus cos squared is always 1. But here we are not able to give that 1 directly. From the given values we have to find it, and we may check whether we are getting this answer or not. Okay, so using the given values, first we have to find what is this one, cos squared plus sine squared, and what is cos squared minus sine squared. So here AB is given as 29 and BC is given as 21. Using Pythagoras theorem, we know that AC squared plus CB squared is equal to AB squared. So AC squared is equal to AB squared minus CB squared. If we want to calculate what is AC, it is root of AB squared minus CB squared. So which is equal to root of, what is AB squared? 29 squared minus 21 squared. On simplifying this one, finally what we are getting, no, it is 20. AC is equal to 20. I'll tell you how to simplify this. Root of 29 squared minus 21 squared. 29 squared, when you take, no, we have to do a lengthy calculation. But I'll explain how to do in a simplified manner. What is the formula for A squared minus B squared? A squared minus B squared is equal to A plus B into A minus B. So A squared minus B squared is equal to A plus B into A minus B. So in the place of A we have 29, in the place of B we have 21. So 29 plus 21 into 29 minus 21. What is 29 plus 21? It is 50. What is 29 minus 21? It is 8. So root of 8 into 50, which is root of 400, which is 20. Therefore, AC is equal to 20 units. Is it clear? Now come to the problem. We got AC as 20 units. Okay, so we have to find what is sine squared cos squared. Then we have to substitute in this. Okay, so first I have to calculate what is sine theta. What is the formula for sine theta? Sine theta is equal to opposite side by adjacent side. What is our opposite side? 20 by adjacent side is 29. And what is the formula for cos theta? What I said? Sin theta is equal to opposite side by hypotenuse. I'm sorry, I said the formula wrongly. Sine theta is equal to opposite side by hypotenuse. So 20 is the opposite side and hypotenuse is 29. 20 by 29. Okay. Cos theta is equal to adjacent side by hypotenuse. So 21 by 29. So sine theta is equal to 20 by 29 and cos theta is equal to 21 by 29. Now number 1, cos squared plus sine squared theta, which is equal to 20 by 29 the whole square plus 21 by 29 the whole square. Okay, which is equal to 20 squared by 29 squared plus 21 squared by 29 squared, which is equal to 29 is square is common, so 29 square, 20 square plus 21 square. I'll write here, which is equal to 20 squared is 400 plus 21 squared is 441 and 29 squared is 841. So which is equal to 841 by 841. Cancelling this is 1. Already we know that sine square theta plus cos square theta is always 1. Here also we are getting the same one. So we got cos squared plus sine squared is 1. Now come to the second one. Cos square theta minus sine square theta, which is equal to 21 by 29 the whole square minus 20 by 29 the whole square, which is equal to 29 the whole square, 21 squared minus 20 squared. 21 squared is 441 minus 20 squared is 400 by this is 841, which is 41 by 841. So the answer for cos square theta minus sine square theta is equal to 41 by 841. Is it clear? Next problem. In a right angle triangle, right angled at B, if tan A is equal to 1, and we are going to verify 2 sin A cos A is equal to 1. So right angle is given as at the vertex B. Okay, so first we have to draw the triangle ABC, and it is given here only we have 90 degrees. Okay, and it is given tan A is equal to 1, and this one only we are going to prove. So this is given and this we are going to prove. For that, first we are going to write the formula for tan A from this triangle. So this angle only we have to take tan A. Tan A is equal to opposite side by hypotenuse. So tan A is equal to BC by AB. Opposite side by adjacent side. So which implies BC by AB is equal to 1, which implies BC equal to AB. So we are getting this one. So AC squared is equal to AB squared plus BC squared. Already we have BC by AB equal to 1. So we took BC equal to AB. We can equate this BC to AB and to a constant K. So K is a constant. So BC equal to AB equal to some constant K. Okay. So this one we are going to substitute here. So we can equate BC and AB to K. So K squared plus K squared, which is equal to 2K squared. Therefore AC is equal to root of 2K squared. What it is? So AC is equal to root 2 into root of K squared, which is root 2 into K. So AC is, when we take this as K and this as K, this is root 2 into K. So BCK, ABK means this is root 2 into K using Pythagoras theorem. Okay. Now come to the expression what we have to prove. What we have to prove? 2 into sine A into cos A equal to 1. Am I right? So for that what we have to calculate? Sine A cos A. Sine A first. Sine A is equal to, this is my A, sine A is equal to opposite side by hypotenuse. What is my opposite side? K by hypotenuse is root 2k. K we can cancel, so it is 1 by root 2. What is cos A? Cos A is equal to adjacent side by hypotenuse. So adjacent side is k and this is root 2k. So 1 by root 2. So sine A is also 1 by root 2. Cos A is also 1 by root 2. Therefore 2 into sine A cos A is equal to 2 into 1 by root 2 into 1 by root 2. Root 2 into root 2, it is 2. We can cancel with this. So finally it is 1. Therefore we have proved 2 sine A cos A as 1. Is it clear?